Hey, fifth grade, Miss Kochbada here. I'm trying out something different today, and actually this is my second time recording this entire video because I thought it had recorded and then it only saved 30 seconds of it the first time. So, but yeah, I'm just gonna try something out today so that I basically have it mirroring my iPad so that you can see me actually writing the work on the packet like you are, rather than just looking at me writing it down. So today is Tuesday, April 7th, 2020, and our joke of the day is, what did Mr. Hamburger and Mrs. Hamburger name their daughter? And the answer is Patty, like a hamburger patty. All right, so we are on week 3, lesson 2. Okay, so you should be looking at this page on the packet like I am. And our objective for today is I can add and subtract fractions with unlike denominators, including mixed numbers. All right, so we're going to go ahead and take a look at our fluency. It says, write as many names as you can for the fractions shown on the geoboard. Each geoboard represents one whole. Then use greater than, less than, or equal to compare the fraction shown to the other fraction named. Okay, so I can see up here that they, turn this on. All right, what they did first is they wrote down this fraction as fourths. So they took their geoboard and they said, okay, if I evenly divide this geoboard into 4 pieces, I can see that 1/4 is shaded in, and that gives me this fraction right here, 1/4. All right. They also said, okay, I can also say, I can divide this up into 8 pieces evenly. So groups of 2, which is going to give me 8 groups. 4 there, and 4 up top, okay? And when I divide the geoboard that way into 8 groups, I have 2 groups that are shaded in, which gives me 2/8, okay? They also said, if I also just think of this geoboard as each unit is just 1, then I have 16 total pieces, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And I have 4 of those 16 pieces shaded in, so that gives me 4/16. And then they said, okay, thinking of 1/4, how many fourths or 16ths, how many 16ths would I need to equal 1/2, right? I would need at least 8/16 to equal 1/2. So that means 4/16 is less than 1/2. Okay, so that's what we're going to be doing. So let's go down to number 1, and we're going to start with fourths like they did. So I'm going to divide this geoboard into 4 pieces, 4 equal pieces, so 4 groups of 4. All right. And I'm going to say, okay, I can see that I have 2 out of my 4 groups shaded in. All right, so this fraction is now 2/4. All right, because I have 2 out of the 4 pieces shaded in. Okay. I can also say, all right, let's think of this as 8ths, okay? And I can say, all right, if I have 8 pieces, if I divide these into 8 groups, so 8 groups of 2, all right, I can see that I have 1, 2, 3, 4 groups of 8 shaded in, so that's the same as 4/8. All right. Now, I can also go back and say, all right, I can also think of these each squares, this geoboard, as 16ths, right? So that means I have 1, 2, 3, 4, 5, 6, 7, 8 out of 16 pieces shaded in. So that's 8/16. All right. And I'm going to use 8ths here since they have 8ths as this fraction to compare. Sorry, let me mute my computer. So if they're using 8ths here, I'm going to say, okay, let's compare this to 4/8. 4/8 and 5/8. All right. Well, that's pretty easy to see right there because they have the same denominator. So I know that 4/8 is less than 5/8. Okay. All right, so moving on to number 2, we're going to do the same thing. All right, if you weren't sure how to do this at first, but now you get it, go ahead and pause the video and try to do it on your own. And then you can check your work by playing the video when I go over it. All right, so I'm going to start with fourths again, dividing this up into 4 groups. Okay. And when I have this divided into 4 groups, I can see that there are 1, 2, 3, total pieces shaded. So this is the same fraction. This is the same as the fraction 3/4. All right. Now I'm going to go back, and again, I'm going to do the eighths. So if this is divided into 8 equal pieces, all right. So 8 groups, I can see that I have 1, 2, 3, 4, 5, 6 eighths represented on this model. Okay. Same thing, going back, trying 16ths. I'm going to say, all right, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 16ths shaded in. All right, now I'm going to compare one of these or all of these fractions to 1/2. All right, so let's use, we can use 3/4 this time. Any fraction you want, whichever one you used is fine. So 3/4. Well, let's think, okay, how many fourths am I going to need in order to equal 1/2? All right, I'm going to need 2/4 to equal 1/2. So if I need 2/4, if 1/2 here is the same as 2/4, then I can think of this as 3/4 and 2/4. And I know that 3/4 is greater than 2/4. So if 3/4 is greater than 2/4, then that means 3/4 must be greater than 1/2. Okay. All right, let's go down to number 3. Now, this one's starting to get a little more tricky. So let's go ahead and start with fourths like we normally did. All right, so you divided your geoboard into 4 pieces. All right, and I noticed I can color in 1, 2, But when I get to this third one, it's only partially shaded in. The whole thing isn't shaded in. So that means it's not quite 3/4. So I'm not going to use fourths because I can't get it even there, and that doesn't make a lot of sense to me. So I'm going to try something different. So now I'm going to try eighths. All right, so again, I'm going to divide my geoboard into 8 pieces. Oh, okay, well, I'll use red. All right, so 8 pieces. And I can see that 1, 2, 3, 4, 5 out of 8 groups are shaded in. So this is representing 5/8. Okay. Now I'm going to use 16ths because those are individual ones, so I know that I can do that. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 out of 16 pieces shaded in. Okay. So now I have 5/8 and 10/16. And I want to think, okay, let's say we use 5/8 is fine. Okay, so now I'm comparing 5/8 to 3/4. All right. Now, this is a little tricky. So I am going to find the common denominator, and I'm going to turn 3/4 into a fraction with 8 pieces. All right. So 4 times 2 gives me 8. So 3 times 2 gives me 6. So I can see that an equivalent fraction to 3/4 using eighths is going to be 6/8. And if that's true, and that means 5/8 is less than 6/8, which means 5/8 is less than 3/4. Okay. Moving on down to number 4. This one is a little trickier because I can see that it has at least one whole shaded in and then some. Okay, so again, I'm going to start with those fourths just to see if I can do it. All right, here I can see that I have all 4 shaded in, 4/4. And now I'm going to divide this one into fourths. I have 1/4 shaded in, but I noticed that again, I'm running into that problem where I only have half of another 4th shaded in. So I'm actually going to erase that, and I'm going to try eighths. All right. So if I'm using eighths now, I have 8 pieces. Okay. All right. And I have all 8 shaded in here. So that's one whole. Okay. And then I have 1, 2, 3 more eighths shaded in. So 1 and 3/8. I also know that I could think of this as a fraction greater than 1. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 eighths, right? 1 and 3/8 or 11/8. All right, and now if I want to think about this as 16ths, again, I still have this as one whole here, so 16 sixteenths, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. But I also have 17, 18, 19, 20, 21, 22. So I also have 22 sixteenths, which is the same as one whole, and 1, 2, 3, 4, 5, 6 sixteenths. Okay? So now I want to compare this to 1/2, or 1 1/2, excuse me. So I want to say, okay, 1 3/8. Well, let's think about this. If I wanted eighths to get to 1/2, I'm trying to think, how many eighths do I need to equal 1/2? I know that I'm going to need 4 eighths to equal 1/2. So I would have to have 1 4/8 to be as much as 1/2. But I only have, or 1 1/2, excuse me. But I only have 1 3/8. So if 1 1/2 here is 1 4/8, and I only have 1 3/8, I know that 1 3/8 is going to be less than 1 1/2. Okay? Take a few minutes, make any adjustments that you need to, and then we'll get started on our daily task. Okay? So, our daily task says find 2 different ways to add these numbers. Okay? So, I'm going to start over here, and I have my 2 mixed numbers, and I'm going to remember the steps for adding mixed numbers. So I'm going to say, okay, the first thing I need to do is I know I need to add my whole numbers and write a new equation. So 2 plus 1 is 3. So I'm going to write 3 1/3 plus 3/5. Okay. So I'm going to keep this big 3 down here, my whole number, and I know that I'm going to have to create 2 new fractions with a common denominator so I can add these fractions. So I'm going to ask myself, okay, what is the least common multiple between 3 and 5? And if you skip count, use that skip counting strategy, you're going to find the least common multiple is 15. All right. So now we're going to find our numerators by multiplying. We're going to say 3 times what number gives me 15? 3 times 5 gives me 15. All right. And then 1 times 5 is 5. Then I'm going to say 5 times what gives me 15? 5 times 3. And 3 times 3 is 9. So now I have 3 5/15 plus 9/15. Okay? So I'm going to keep that 3, and I'm going to say 5/15 plus 9/15 is going to give me 14/15. Now looking at this fraction, I can see that this is not a fraction greater than 1, the 14/15, because my numerator is smaller than my denominator. And I also can see that there is nothing that evenly divides into 14 and 15. So that means my simplified and final answer is going to be 3 14/15. All right, so that's strategy number 1. Okay, now we're going to do another strategy over here. Okay, one that we haven't really done quite as much is you can take 1 1/3 plus 2 3/5, and you can actually change both of these mixed numbers into fractions greater than 1 before you start adding. Okay, or before you start, well, adding, but also finding the least common multiple. So remember, to convert a mixed number into a fraction greater than 1, you take the denominator and you say, okay, 3 times 1 is 3. And then 3 plus 1 is 4. So that's going to give me 4/3. Ariana used to call this the zigzag method if you were in 5B. All right. Then I'm going to do the same thing here. 5 times 2 is 10. And 10 plus 3 is 13. So that gives me 13/5. So now I have 4/3 and 13/5, so I'm just going to find that least common multiple again, which is still going to be 15. Okay. And now I'm going to multiply the same way. 3 times what gives me 15? 3 times 5. And 4 times 5 is 20. All right. Then I'm going to do 5 times what gives me 15? 5 times 3 gives me 15. And 13 times 3. If you don't know that off the top of your head, that's okay. You can say 13 times 3 off to the side. 3 times 3 is 9, and 3 times 1 is 3. So that's going to give you 39/15. Okay. Now I have 20/15 plus 39/15, and what does that equal? Well, I know that 39 plus 20 is going to give me 59/15. And now I need to figure out, how can I put this into a mixed number? So I'm going to ask myself, how many times does 15 go into 59? And if you're not sure, you could come down here and do, okay, 15 times 2, 15 times 3. All right, and ultimately you're going to get 3 because 15 times 3 gives you 45, which is as close as you can get to 59 without going over. So I know that 15 goes into 59 3 times. So 3 is going to be my whole number. And 3 times 15 is 45. So I'm going to ask myself, okay, how much more do I need to get from 45 to 59? I'm going to need 14 more. And my denominator stays the same, which is 15. So once again, I was able to get 3 and 14/15. Okay? All right, so after you finish that, go ahead and scroll down to our exit ticket. So this says solve with a visual and the standard algorithm. We hadn't really gotten into visuals necessarily with subtracting mixed numbers and fractions when they have different denominators. We had used the number line when it was the same denominator, but we had really just started working on that standard algorithm. So we're going to use that here. So if you don't have a visual, that's fine. But if you did solve it using a visual, that's great too. Okay, so to start, remember when I have one mixed number and then just a regular fraction, I'm going to put this mixed number into a fraction greater than 1 before I start subtracting. So I'm going to say, okay, 4 times 1 is 4, plus 3 is 7. So that gives me 7/4, minus, keeping this fraction the same, 6/7. All right, so now I'm going to find that LCM, and I can do that by skip counting. So if you need to, you can list your multiples while you skip count over here. All right, and eventually you would find that the least common multiple between 4 and 7 is 28. All right. So now I'm going to ask myself, all right, 4 times what gives me 28? 4 times 7 gives me 28. And 7 times 7 is 49. All right. 7 times what gives me 28? 7 times 4. And 6 times 4 is 24. Okay. So when I subtract 49 minus 24, it's okay if you can't do that in your head. You can come down here and subtract. And you would get 25. All right. So now that gives me 25/28. All right. I know that this is a fraction less than 1 because my numerator is smaller than my denominator. All right. And there is nothing that divides evenly into 25 and 28. So I know that my final answer here is 25/28. All right. So that is all that we have for today. If you have any questions, please reach out. Please don't forget to send me pictures of your work. I'm trying to think who did it most recently. Tyrese, shout out to Tyrese. He sent me pictures of a lot of his work. And fourth graders have been sending that. Darius usually does. I'd really like to see more people sending me pictures of their work and letting me know that this has, been helpful for you. Okay, so please enjoy this beautiful day. Make sure you're staying safe, staying away from people, especially during these peak times of the virus. But make sure you're, staying healthy, getting some exercise, and washing your hands, all right? I will be back tomorrow for week 3, day 3. So I will see you guys then. Bye.